Greetings, fellow scholars. Here we are to talk about investments, sales, and profits. In this scenario, we're going to calculate simple interest compounded annually, as well as compounded continuously. We're also going to calculate intercepts and vertices of quadratic functions and some variable values. We're going to do all of this in Excel while we build tables, line graphs, exponential graphs, and quadratic graphs. Before we start, let's take a look at a couple functions. This particular function is a correlation function depicted by a line. This line shows us that as time moves on, so our horizontal axis is time, and this is 20 minutes, 40 minutes, 60 minutes. As time is moving forward, our boring company is boring downward. So it looks like after 20 minutes, our boring company has bored down 2 meters. So if you look at our rate of change here, -1/10, -1/10 means that we are moving down 1 and to the right 10. So the numerator represents the up and down, rise over run. People have heard that before, but we're not interested in all that. We just want to make sure that we can read our graph and we know that we are moving at a constant rate. Now, look here, this is still down 10 to the right, down 1 to the right 10, but we just changed it, down 2 to the right 20. And if we come up here and change this fraction, you guys can clearly see that 2/20 reduces to 1/10. They are equal. And our rate continuously changes, the same, down 1 to the right 10, and that just continues going. That's what a function is, which is why it's a continuous function, why we need that arrow right there at the end of our line. That's important. We're going to put arrows in all of our continuously functioning graphs. All right, let's move on and see what else we're going to look at. This was just a reminder, this was a negative slope, a negative correlation. As time moves on, the depth is decreasing. So what about a positive correlation? Well, in this case, we have a runner. As the time is moving forward, the runner's distance is increasing. You see that? It's a positive correlation. Time's moving forward, distance is increasing at the same rate, but this time instead of negative, it's positive 1/10. So we go up 1 to the right 10. And then that pattern is continuous. Now, what I thought of is if I were a runner and I was starting off, I don't know if after 120 minutes, I would still be running at my constant rate of 1 mile every 10 minutes. So I thought, even though we don't study logarithmic functions, I thought I would throw one in just because it made sense. If I were running, it would probably look more like a logarithmic function. I would start off at some speed that seemed about normal, and then I would taper off. I wouldn't be able to run as fast as time went on. So a logarithmic function, even though we're not studying them, depicted the scenario better than what I thought the linear function did. Now let's talk about quadratics. This is a parabola. Parabolas are really cool. They have an equal. If you took a parabola and you split it down the center and folded it in half, it would sit right on top of each other. It's perfectly symmetrical. So this particular parabola is depicting a rocket's miles per second. So this rocket moves. If you look right here, it looks like it reached about a maximum height of what, maybe like about 135 or so. Not quite in the center, between 500 and 600, so maybe 130, 140. So that reached a maximum height of about 540 feet in a little less than 6 seconds. You see how that correlates right there? This is my maximum height, and it comes down here to reach my horizontal line. So I know after about 5.5 seconds, it reaches a maximum height, and then it starts falling down at the exact same rate that it was going upward. So let's see why that happens. Well, when we're dealing with parabolas, we are looking at a function that represents, in this case, velocity. So this 85 right here is the actual initial velocity that this red line is depicting, that this rocket was shot up at 85 miles per second. I know I have miles per second in one, and then distance in feet over here. So I clearly was cutting and pasting and got a little carried away. So this is supposed to be rockets in feet per second, is what that's supposed to be. So you guys can now see here that we had our initial velocity, and then what happens is gravity comes in. And all of these little dotted lines are gravity pulling us down here at a constant rate, at a rate of 16 feet per second. So this negative 16 right here represents the force of gravity, negative 16 feet per second. And that gravity is happening at a very constant rate. So it's working against the velocity until it can pull the object to the ground, which is what we find right here. The object hits the ground at about 11, maybe 11 and a half seconds. But let's look over here. When we actually do this scenario on Excel, we're going to be looking at different things. We have our initial starting point, and then we have the place on the graph. The place on the graph where we hit our maximum height. If you look here, you can see that we had 525 feet, and here it was 484, and on the other side, I'm sorry, 534. Let's look at 534. And if you look on either side of 534, you'll find the numbers are smaller. So it looks like somewhere around our 6 seconds is when we hit our maximum height. And then we see where it hits the ground. Well, look here. Somewhere between 11 and 12 seconds, we hit ground zero, because it went from 100 feet in the air to 84 feet below the ground. So in that, and of course that wouldn't be the case. That's where it hit zero sometime in between, unless it went over a cliff or something. And the rate would definitely change once there was interference or friction of any kind. So hitting the ground, it would not go down 84 feet per second. All right, let's see what else we have on here to look at. Here is another parabola. This parabola is facing upward. In this particular case, we're talking about a profit and investment. So it looks like we invested some amount of money. Our ground zero, oops, that's not my pointer arrow, that's a different arrow. Our ground zero is this line right here. And it looks like we had an initial investment of $200. So you see when we had zero sales, we were, well, you guys don't know this, but this, let me show you. In Excel here, I just created these graphs for this PowerPoint presentation. But here, you see where it has the parentheses around these numbers? It's because I chose the number. If I go back up here and go to currency, and just change it to dollars, it will give me my negative. So before I copied and pasted this, I accidentally just pressed American English dollars instead of actually going up to here and pressing currency and then making it dollars. So that's the reason why in my PowerPoint presentation, it just has these parentheses rather than the negative sign, just so you know why. But this is negative $200. And it comes from right here. You see this initial investment, negative $200. Well, we didn't have that on this function. This one was just plus zero, which we normally don't record the zero, but I just put it there to show you guys. This graph started at ground zero. So that last value actually tells us where our graph starts and is going to be our initial y value. Now here, our graph starts at negative 200. You see right here, negative 200, and it starts down here. Now this was profit according to sales. We have an initial investment into a company, and then even though we're selling products, we're still losing money because we had to buy materials, we had to hire people, we had to buy machines. all the things that rent a building space, all of the things, pay taxes that you have to do to run a business. You start losing some money in the beginning, but then you hit bottom, you hit your bottom dollar, and then you start making your way back up until you break even. This is your break even point right here, somewhere a little after 12. And if you look here, these parentheses signifying negative numbers, somewhere between 12 and 14, we did in fact break even, hit that 0 point. And then our bottom dollar, where's that going to be? Right here, 734, right at about 6 sales, right here. We hit our lowest point. And you can see that here in the chart because on either side of that, the numbers are getting bigger. 684, negative 684 is more than negative 734. And if that confuses you, think about your checking account. If your checking account was negative $700, that's worse than if it were negative $600, right? Hopefully that does not happen to any of us. All right, the last thing that we're going to discuss here is simple and compound interest. So for this last little piece, I just wanted to show you guys these different graphs. This green represents our initial investment. If we put an investment in to the bank and we don't do anything with it, then it does not change. It stays the same. If we put an investment into the bank and we collect simple interest, then our investment will increase to some degree, right, depending on the interest rate. But if we're looking at increasing our investment with compound interest, we can grow our investment very quickly, which is, of course, what we all want to do. But when you're playing with stocks and bonds and different types of investments, you're not always guaranteed that your graph, let's see if I can pull this off, your graph could actually end up, I don't know if this is going to work. I don't think this is going to work, but you might get what I mean here. You might end up upside down if you invest in the wrong thing. All right, you guys, I think that was the end of that, and we are ready to get calculating in Excel. So I'm going to open my Excel. This is going to go pretty quick. I have my document page here to tell me everything that I need to do. You guys have a couple things you can click on. We're going to explore Elon Musk, if you don't know who he is. He's one of the founders of PayPal, Tesla, SpaceX. I don't know. He's done it all. He's considered to be one of the most productive people on earth. He does a lot. He works a lot of hours. He runs a lot of companies, and he makes a lot of money. But he invests all of his money back into his companies that he tries to create companies to help the greater good. So I really like Elon Musk. I put a couple links here if you guys want to take a look at some of the things he has to say. This is how he started his flamethrower business. It's interesting. But these two links are optional. You guys can click on. This one down here on Part Charlie, you will have to click on this link in order to answer your 5 questions. So explore these two if you want to, but you do have to look at least at the business model. All right, we are going to just dig right in here. We have a couple of formulas we're going to be using that we're going to copy and paste out of the document. But here, we're going to start off talking about just what we did in that last graph. We're going to look at investments and sales. So here, I am going to create a chart that says sales and profit. And my profit is going to be this function here. My function is P of X. And I would cut and paste it, but really the cut and paste thing is getting quite complicated. It does a lot of weird stuff when I cut and paste, so I don't think I'm going to be recommending that until I can get that figured out. All right, so here's my function. I'm going to go ahead and wrap this cell, or I could extend it. I don't know. What do you guys want to do? Extend it? Wrap it? I don't know. It's good either way. So then now on my sales, I know if I have 0 sales, let's see what my profit's going to be. Well, I'm just going to use this function that I just created up here. What was this, 500x? Let me explain what this function means. Let's go ahead and make this big. This P of x means profit according to whatever my variable is. And in this case, my variable is x. X is going to represent the number of sales that I'm going to have. So profit according to sales is going to be 500 times x, and this is my x value over here. Okay, now I'm going to go ahead and increase this by 20. So I'm going to go from 0 to 20, and then I'm just going to drag this out a little bit. That should do it. Now I have this function here, 500 times x. So I've actually never seen Excel do that for me. It just automatically plugged in x. So you guys, I don't know if it will do that for you, but you can paste that in there, and then I'm really surprised right now because I've never seen it do that. And then I'm going to hit the multiplication because that's 500 times x, and then I'm just going to click that over there. Now I'm just going to double click this, and voila, it will fill in the rest of my chart. So a couple other things. I'm going to make it pretty. I'm going to give it some borders. We're talking about money, so I guess I'll use green, but we already used green. So I don't know, we can use green twice. That's perfectly fine. Select my data, insert a line chart. Don't forget, guys, that you have to label all of these. I know I keep saying it, just don't forget to add your axes titles here, okay? And also, you're going to click this line, double click it, and then come over here to your paint can and add an end arrow. All functions have to have an arrow on the end. All right, you guys, this is really all I want you to do here. We're not going to spend a lot of time talking about this particular case because what is this? This is profit according to sales if you don't have any costs, if you had no initial investment, if you're not paying rent on your building, you know, all of the things that can change the way your profit and sales function works. This is a very basic linear model. And like we discussed in the PowerPoints, it's just really not the kind of model that you would use to truly calculate the sales, the profit according to sales of your company. So what we're going to do is I'm just going to copy and paste this chart since I've already got it going here. I don't have to redo a lot of that. And then I have this function over here. So I'm going to copy this function. And then I am going to paste it right into here. I'm not going to do that. I actually just changed my mind. I'm just going to go ahead and type it in. So I'm going to pause the video and type it in. Okay, I typed it in. I'm going to go ahead and wrap my cell just to keep it looking nice here, because that one's just a little too wide. And I'm just going to center these. I know I didn't center this one. It didn't really seem to matter that much up there. All right, now I am also going to make these bold. I know this is ridiculous of me, but I can't help it. Okay, so I am going to look back here at my instructions. I am going to create a scatter plot. I'm sorry, a smooth line scatter plot. That's correct. But this is the thing I'm worried about. When I get all the way down here, it says that I need to figure out how many flamethrowers Elon Musk sold to make a profit of, I thought it said $90,000 somewhere. Let me pause the video. Okay, here's what I'm looking for right here. It says to find out the number of sales and calculate the profit after 300 sales. So what I need on my chart here is I need this to count all the way to 300. and it only goes to 160. So I'm going to go ahead and keep going here. You see the little numbers changing over on the right? All right, all the way to 300. And now I have all of the data that I need to continue on with this scenario. So I'm going to select this set of data, insert a smooth line scatter plot. And I did not get what I wanted, so let's, I see exactly what's going on. I put my function, I did not put my function in here. So I am going to grab this piece up here. Excel didn't do that cool thing for me again, did it? I don't know how that happened. It doesn't really turn out that good for teaching, but it would be cool if I could recreate that for my own purposes. All right, so this is going to be times x. And I'm just doing the same thing. This is 6.212 times x squared minus 1200 times x minus 1200. Sorry, I know it's so small. And you guys can see here what I've put in. Now I am going to just make that go all the way down, select my chart, and now I can insert my smooth line and it will be exactly what I want it to be. My axes titles, of course, and add my arrow, my end arrow here. Because it's a continuous function. Now let's go ahead and see what happens. I did have some parameters to use here. If your graph is not turning out good, you can change it to use these parameters, but it looks like everything that I'm showing here, well, not really, because I had an initial investment of $1,200 and my line really looks like it's on zero, but it's not. And look how I have a distance here of 5,000. So I am going to go ahead and use the parameters that I posted here. All right, now we are going to go to the axes. Double click your axes, or you can right click and format chart area. And then once you do that, that won't work. Double click your axes. And then click on this little graph icon over here. Go to axes options. And here we are. So this one is negative 75,000. The next one is 100,000. And you guys can't see, but my graph is actually changing as we type this in. But I'm not quite done. What was my last piece here? My major is 2,000 and my minor is 4,000. So let's see. My major is 5,000. And my minor was 4,000. All right, now it looks a little busy, but that's okay. We need all of this. I'm gonna go ahead and just make my graph. I'm gonna pull it apart, make it longer here. And I think, let me just double check those parameters. I'm gonna pause the video and check something. I'm just not really getting the look I want. So I'm gonna make my graph smaller, or minimize that. I'm going to make the graph bigger. See if this is going to help at all. But I still don't see it helping, so hold on. Okay, I'm going to have to change the parameters that I posted in the page. But for now, let's just have a look at how to change these parameters. First of all, I'm struggling because I have an initial investment of $1,200 and my graph is not, it's too close to zero. I need to see better. I don't feel like I have a clear vision of what this is supposed to be showing me. So I'm going to get rid of all of the excess stuff that I have. First of all, my bottom dollar, you can see is somewhere around 100 sales. So I'm going to go over here to my 100 sales, and I see that that's about negative 60,000. So I'm going to make my absolute minimum value here. It's at 75,000. I'm going to change that to 60. That'll give me a little more room down there. And then up here to the top, I needed to find out how much money did he make at 300 sales. So that looks like it's right about here, about 300 sales. It doesn't even look like we have quite made it up to 300 sales. So what we're going to do is I'm going to change my minor here, my major, to be 500. Okay, I did actually go back in again and just type in these values: negative 75,000, 100,000, 20,000, and 4,000. So just follow along with what I posted over there. It'll get us where we need. So I did actually have this beautifully done. I try to work these out before, and I created this graph down here to show you guys. And this one very nicely depicts my $1,200. And when I click on this axis, you can see that the values are exactly what I've given you guys. So why it's not working, I can't exactly tell you, but it's not going to take away from what we're going to learn here. I just wanted you to see that that was down there. And I did do a better job. I just can't seem to get it to work this time. So I'm just going to click this line again and add my arrow. The arrow is important. It may not seem super important to you guys, but it is. All right, so I'm just having a little bit of struggles with Excel here now. So my end arrows, hopefully, let's see if this will work. Nope. I think Excel gets tired sometimes. And I've actually been at this all day. So I'm going to not worry about the arrow right now, but you guys go ahead and put that arrow on there. And let me show you what else we're going to do here with this scenario. We are going to mark the places on this graph that correspond. We talked about this when we did our Excel, our PowerPoint. I am going to actually increase my font size on this chart just to make it a little bit bigger, make it look better. Is that too big? All right. Now I am also going to just make everything a little bigger so we can see it better. Now, insert an illustration. And if you're clicked on your graph and you try to insert, it's going to do weird things. So make sure you're cleared from clicking, having anything selected. Insert illustration, a shape, and then choose something. I'm going to choose this little lightning bolt right here. You can choose anything that you can find. I've actually had a couple people do little flamethrowers of the actual flamethrowers that Elon Musk sold. So look right here. You see, this is my initial investment. I'm also going to make these numbers bigger if I can. So my initial investment right here, I'm going to paint that blue because that's what color my icon is. All right, that is the amount that I initially invested into my business, $1,200. I'm just going to copy that, and I'm going to come down here on my bottom dollar. When I hit my bottom dollar down here, I'm going to paint that one red. Red makes sense to me for that. My bottom dollar happened somewhere around 100 sales. You guys see that? Right around 100 sales, we ended up, I don't know why that changed colors on me. So right around 100 sales, we hit our bottom dollar. So I marked that. You see I'm color coding that. And then the next piece is, whoa, is when did we break even? So now, right here, I'm actually going to break even. And breaking even is good. Let's see, what would be a good color for breaking even? Orange, we get happy. We're not losing money anymore. So where is that going to be here? Somewhere between 180, 200 sales. So I'm going to go ahead and mark it at 200 just because it's, we didn't hit a break even before 200. So it was somewhere between 180 and 200. And of course, we counted by 20s. I could have made this chart much longer and counted by, tens or fives, and we would be able to get much closer to these values. All right, now the next thing that the scenario asks us to do, hey, look, I didn't need the arrow after all. I got my own arrow right there. So we can put this one as green because that is what happened after we sold 300 flamethrowers is that we profited $2 million, or I'm sorry, about $200,000. So once we hit 300, this actually goes up. 300 would go up more. And you guys can, correlate that however you want to. You can show that this arrow is going upward and you correlated it here. You can make your graph bigger. You guys can make some decisions on what to do there. All right, don't forget to label your axes. These axes titles will not do. They are way too small, so please make sure that you have your axes titles big enough to easily see. Because if they're that small and I can't see them, then I'm probably not going to give credit for them. Because they need to be visible. The credit is not just if you did it, it's if you did it well enough to depict the information clearly on a graph. All right, and you guys can do stuff with these graphs. This graph, for example, you can right click and format the chart area. You have your paint can, you can fill it in with a gradient color, and you can change these colors. You can do all kinds of cool stuff, which I never knew about until last semester. So have some fun with that. All right, the last piece that we are going to do is calculating some interest. So we're going to suppose that Elon Musk has a marketing manager who wants to allow others to buy into the flamethrowing company. So in other words, the marketing manager is saying, look, we want to really grow this business. We need investors. So we're reaching out to you, and we promise that if you invest in our company with a $5,000 buy-in, that we can offer you one of these three returns on your money. Either 6% simple interest, 6% interest returned compounded annually, or 6% interest returned on continuous compounding. So we're going to see what would Elon Musk's marketing manager want to offer to investors. And here I have put all of these charts and graphs for you to copy and paste, even though we now know that that's not going to be an option. So I'm going to pause the video and type this in. All right, here we go. So I have also gone in and filled in the $5,000 principal. That is our initial investment. The principal is our initial investment. The interest rate is 6%, and our time is depicted in years, and that's going to be in this column right here as soon as we get to it. And then here's the number of times that we do a compounding. So we have all of our formulas ready for us, typed in right up here. Let's see, I'm going to make this piece just a little longer. All of our formulas are typed in, so now we can just see exactly what we need to gather. For the number of years, we are going to start off, we'll just do 1 year, and then 2 years, and then we'll just take those down. All right, then we are also going to look at our simple interest. Our simple interest is this simple formula. It is equal sign, the principal, times, open parenthesis, 1 plus the rate times the time, which is right here. Close parenthesis. Press enter. But wait, let's talk about this because our principal amount is not going to change. So we do need to lock that cell in. And our interest rate is not going to change. So we also need to lock that cell in. Our time, though, is going to change. So we'll leave that there. All right, very nice. Now I have my compounded quarterly interest, but I'm actually going to change this to a yearly compound. Was supposed to say yearly. So now here I am going to again put my my equal sign. I was just thinking I could actually copy this and paste it in here and just change a couple things because I already have my interest times 1 plus, and then I have to change this right here. This is going to be 1 plus open parenthesis my rate, which is already there, divided by the n, which is the number of times it's compounded, which is this number right here. And I do need to put, okay, rate divided by n, and then close my parentheses. Don't forget your parentheses, guys. They're very important. Can't do math without parentheses. All right, and then that amount is going to be raised to the power of the number of times it's compounded times the number of years. Right there. Okay, let's see all my parentheses. I have open, open, close, close, open, close. Everything looks good. I need to lock in all of the values that are not time because all of those are going to stay the same. Press enter. And then bring it down. Bring it on down. All right, now continuously compounded interest is equal sign principal amount, which is the same thing as an investment, what we're going to invest initially. And then E. Well, E, folks, is, I'm going to press time. E is what we call a transcendent number. It's like the number pi. We're going to actually explore E a lot more in Module 2, but for now we're just going to go ahead and use it. But it's just like pi is a constant, E is also a constant, and we'll look at what that means later on in the term. But for now, let's go ahead and EXP is E, so you just double-click EXP there, and then type in the number, which in this case is RT. So that's going to be R times time. And then, of course, again, we're going to lock in all of the cells that we do not want to change. And E automatically means an exponent. That's why I didn't have to use the little raise thing. It's the exponent gets put right into these parentheses. All right, hit enter, and now you have this. So yes, this data, we can see all of this data, but wouldn't we like to see it in a graph form? Yes, that would be quite fabulous. So I'm going to go ahead and choose all of this. Don't get that top piece. It will mess up your graph. And then I am going to insert some smooth line scatter plots. All right, now you guys can see, I'm going to go ahead and change my axis. See all this excess axis I have down there? I'm going to take that off and make my minimum value be 4,500. How about that? My minimum value here is going to be 4,500. And now I can see just a little bit better. So our blue line is our simple interest. So I'm going to go ahead and make that blue. Because I made that blue, I'm just going to change my border up there to be something that is not being used. I guess this lovely magenta that we gathered earlier. Here is my, my annual compounded interest. So this one I'm going to paint orange. And then my continuously compounded interest looks like it's gray. I'm just correlating these to what's on that chart over there. And I could have swore I changed this to annual. Or did I type it? Just typed quarterly back in there. All right, so now I can clearly see my lines. So would Elon Musk's marketing manager want to market to investors that they would get back a simple interest amount, an annually compounded amount, or a continuously compounded amount? Well, I guess it just depends. If they're completely confident that they can offer a fantastic turnaround on the money, they want those investors right now, so they're going to offer a compounded return on your investment, an ROI, return on investment. So if they really want that money right this second, then they might sacrifice and lose a little bit more later on. If they just are looking for investors, sometimes companies are just letting people invest so that the community can become part of the company. In that case, they're not really desperate for money right now, and they might just offer a simple interest return on investment. So I think that's it. Let's go ahead and look at our page here. And we have done all of the things that are on here. And we talked about everything. So you guys are just going to look at these 5 sentences. And I've already discussed all of the reasons between the PowerPoint and this Excel scenario. So guys, I will see you on the next video. Until then, keep being amazing. You rock. We rock.